day, great learners. How are you? I hope you are fine. I am Skulile Ncube, and we are going to look at simple and compound growth. Okay, we're going to look at simple and compound growth. Right, this lesson is proudly brought to you by the Gauteng Department of Education. I really hope that you are ready for the lesson. Make sure that you have your book with you. Today we're going to be using our books and the calculators a lot. We're going to be calculating, okay? So make sure that you are ready. Right, so by the end of this lesson, you should be able to use the formula of simple growth to solve problems. And then we're going to use the formula for compound growth to solve problems. And then we're going to understand what interest is, what interest rate is. And then we're going to identify the factors that affect interest rate. And the most important thing also, we're going to see the difference between simple interest and compound interest, or simple growth and compound growth. Okay, right. So we've done basic calculations. Remember, when you're calculating percentages, we're going to use those in this lesson. Right, before we move any further, greetings, I want us to do this baseline activity. Let's do it this way. We're going to do question 1 for 3 minutes, and then we're going to do question 2 for 2 minutes, okay? So question 1 means 1A and 1B for 3 minutes, and then question 2 for 2 minutes. Let's start with question 1 for 3 minutes. Right, welcome back, greetings. Did you manage to do the activity? Okay, let's mark our work now. Let's mark our work. So make A the subject of the formula there. It means we are saying we must get A is equal to. Remember our knowledge or what we learned when you're doing literal equations? Do you remember that? Right, so we're making A the subject of the formula. What do? We want to remain with A only here. So we must divide both sides by the bracket. There's no need to distribute A. You just the whole bracket as it is. So we're going to say y over divided by 1 plus bx like this is equal to A, and then 1 plus bx like this divided by 1 plus bx like this. You see that? And then this bracket divided by this bracket will give us 1, isn't it? So we're going to remain with A is equal to y over 1 plus bx. Can you mark that? And then we have done A. Let's go to B. How do we do B? Make B the subject. What are we going to do? So we have to remove everything that is attached to B. Okay, so can we do this one differently? Maybe. Okay, so we have A and then 1 plus B times X. And then what do? Let's get rid of this A here. So we divide by it on both sides of the equation. Divide by A, divide by A. You see that? What you do on the left, you do on the right. So we divide by A there, divide by A is 1. So we remain with y over A is equal to 1 plus bx. We have this plus 1 here on the left hand side. Remember 1b. So what are we going to do? We have to subtract 1 from both sides, or we transpose, bring positive 1 to the left, and then becomes y over A minus 1 is equal to bx. You see that? So now still there's x which is attached to b there. We want b to be the subject, so it must be b is equal to. So what do we do with this x? We divide by it on both sides of the equation. So we divide by x, divide by x. So x divided by x is 1. We remain with b there. So it's going to be y over A minus 1 divided by x like this. You see that? That's what you're supposed to do. Can you mark that? Right. Now we're going to do to question 2, and then I'm going to give you 2 minutes to do it. Okay? Right. Let's go to question 2. 2 minutes. Right, welcome back, Cretans. Let's see. We want to find the value of y if A is equal to 10,000 and then if B is equal to 5. So what do we do there? Where there's A, we put 10,000. Where there's B, we put 5. That is basically substitution. Right, so we substitute them, And then you see that where there's A, we put 10,000 here. And then where there's B, we've put 5. Then what do? We don't need to do a lot of things here. Just put this thing as it is into your calculator. Please use your calculators. Okay, use your calculators. We must get the same answer. You can try to do that. So it becomes y is equal to 15,386,23. Then rounded off to 2 decimal places is 15,386 rand, and it's not rand, just the amount. Okay, it's fine. So it's 15,386,24. Okay, right. So if you check what we've done here, it's like we're introducing ourselves to the formula for what? For simple interest and formula for compound interest. Okay, now let's discuss the simple interest. But before we do that, let's talk about the interest and interest rate. Right, interest is the amount of money. Interest is what? Is the amount of money earned from an investment or paid to a loan. If you take a loan, you pay interest. If you make an investment, you earn interest. And then interest is the amount of money. It is in rands if you invested in rands, okay? Right, and then the interest rate is the rate of interest expressed as a percentage. That's the interest rate. So you must know the difference between interest and interest rate. Interest rate is the percentage, and then interest is the amount of money. Okay, right. Interest earned, paid, or paid depends on the following. What will it depend on? The amount of interest that you're going to earn or pay will depend on what? It will depend on the amount that you have invested or the amount that you've borrowed. If you invest more money, you'll get more interest. If you invest less money, you'll get less interest. If you borrow more money, you'll pay more interest. You see that? So interest depends on the principal amount, that is the amount that is borrowed or the amount that is invested. That's the principal amount. What else? The period is very, very important. Right. The period. Like if you invest money for 1 month, are you going to get enough interest? No. It's going to be very, very minimal. Okay. But if you invest for a longer time, you'll earn what? You'll earn more interest. Okay. So the period also will affect the amount of interest that you earn or pay. You stretch and you pay your loan after a longer period of time, then you pay more interest. You see that? But if you reduce the loan period, you'll pay less interest. And then the other thing that will affect interest is the interest rate itself. Okay? If you invest money where they're giving 5%, while there's a place where they're giving 10%, you'll gain less. So the higher the interest, the higher the interest rate. Sorry, the higher the interest rate, not the interest. The higher the interest rate, the higher the interest that you will get. Remember, there's a difference between interest rate and interest. Okay? Again, later in other grades, we're going to talk about the compoundings. How many times is it compounded and all those things. All those things, they affect what? They affect the interest you're going to get. Right. Now, let's talk about simple interest. Simple interest is calculated on the original amount invested or borrowed. What do I mean by that? If I borrow 10,000, let me talk about investment. Right, if I invest 10,000 and then I'm earning interest on that 10,000, even if my investment grows to 20,000, I'll be still in what? Getting interest from that 10,000 that I invested. You see that? So the interest here will never change. So it's always calculated on the original amount. Let's look at this situation here. Consider 5,000 invested for 3 years at 10% per annum. It means 10% per year. First year getting 10%. Second year getting 10%. Third year, you're getting 10%. Right. Now, simple interest. Calculate the accumulated amount for each year. So, first year, what will be the accumulated amount? It means we have the 5,000 that is invested plus the 10% of 5,000. You can put that in the calculator. Just say 10 over 100 times 5,000. What is 10% of 5,000? That is 500 Rand. You see that? So, first year, it means at the end of the first year, we are going to be having 5,500 in the bank. The money has gained interest. How much do we have in the bank? 5,500. Now we're going into second year now. How much do we have in the bank? 5,500, isn't it? But now, in the second year, it will be that 5,000 that was invested initially that is going to gain interest. You see that? So second year is still 10% of 5,000. Yes, the balance has grown. It's now 5,500, but the interest is still on the original amount that was invested, which is 5,000. So it's still 10% of 5,000. How much interest here? 500 Rand. You see that? Say 5,500 plus 500 Rand, which is what? Which is 6,000. So you keep on adding the same amount, plus 500 Rand, plus 500 Rand, plus 500 Rand. Let's do the last year, third year. The balance now in the bank is now 6,000. Is the 6,000 going to gain interest? No, it is the original amount that was invested that gains interest. So it's going to be 10% of 5,000. You see that? Okay, so this is 500 Rand. And then we get 6,500. So simple interest is the interest calculated on the original amount invested or borrowed. But now, great tense, we say, Mr. Ncube invested 5,000 for 10 years at 10% per annum, simple interest. Now, am I going to calculate every year, first year, second year, third year, up to the 10th year? It's going to be a problem, isn't it? How can we make our life easier? There is a formula that we use. There is a formula that we use for simple interest. Okay, this is the formula here. Oh, before we go to the formula, I forgot about this. Notice that the interest is the same every year. I think you notice that is 500, 500, 500, okay? Right, for simple interest, the interest is the same every year. Right, let's go back to the formula. Right, so now we cannot calculate, let's say I'm investing for 20 years now. I cannot calculate first year, second year, third year, up to the 20th year. No, there is a formula. Okay, let's go to the formula. This is the formula. Write it down. Write down the formula for simple interest. A is equal to P and then times 1 plus IN. Write down the formula for 30 seconds. Write down the formula, simple interest formula. Simple interest formula. Okay. What are these variables? What are these variables? What is A? What is P? What is I? What is N? Right. Where A is the final amount, the accumulated amount. Okay, the accumulated amount. Like there, when you calculate it for the first year, we say that 5,000 grew to 5,500. 5,500 is the accumulated amount. Okay, right, or the final amount. And then P is the principal amount, the amount borrowed or invested. Like the example we're talking about there, the principal amount is the 5,000. You see that? That's the principal amount. And then I is the interest rate as a percentage. So you can write it as a decimal. I'm going to show you that. Or you can write it as a fraction. Okay? Then N, number of times interest is paid. I like this one. It says number of times interest is paid, because most of the times we confuse this N and think that N is the number of years. Okay? It is not the number of years. It's number of times the interest is paid. Please take note of that. Now in grade 10, it is safe to say N is equivalent to number of years, because our compoundings in grade 10 are done annually, are done yearly. But when you're going to higher grades, grade 11, we're going to talk about compounded monthly, compounded quarterly, compounded semi-annually. So our N is going to change there. It's not going to be number of years. But now, just know from now, just know, remember this. N is not the number of years, but number of times interest is paid. It's only that here we're going to be doing compounded annually per annum. That's why our N is going to be equivalent to the number of years. Okay. All right. Take note of that. And then, oh, okay, I want you to copy this. All right, let's have 1 minute to just make a few notes. Let's have 1 minute. Welcome back, returns. I hope you managed to write a few notes there. Let's continue, or before we continue. Right, so now we have our formula for simple interest. It's not about finding A only when you're looking at this simple interest. So you can be asked to find A, can be asked to find P, you can be asked to find I, you can be asked to find N for simple interest. And then N for compound interest, we're going to do it later. Right, okay, in grade 12. But now, for simple interest, all the 4 variables, you should be able to find them. A, P, I, and N. So that's what we're going to do. I have 4 questions. The first one, we're going to find A. Then the next one, we're going to find something. I don't want to tell you which one. You have to discover, you have to look at the information and find out what is given, what am I finding out, okay? Right, let's go there. Right, consider 5,000 invested for 3 years at 10% per annum, simple interest. Highlight the important information. This is 5,000 invested for 3 years. In the examination, that's what you do. Highlight 10% per annum, simple interest. Because in the exam, you have to know which interest it is. Because now you know now we're dealing with simple interest is fine, but in the exam now you have to tell, is it this simple interest? Is this compound interest? Okay, you have to know that. Calculate the accumulated amount. What are we looking for? Right, after 3 years, use the simple interest formula. Oh, this one is clear. Okay, if you check, this is the example that we used when you're doing first year, second year, third year. So I want to show you that the formula is going to give us the same answer. And then at the same time, we are learning how to find A. Right, so write the formula for simple interest, which is this. And then look at the information. What are we given? What is this 5,000? Is it A? Is it P? Is it N? Is it I? That is P. Write your information. Write your data. P is equal to 5,000 rand. When you do that, it becomes very clear for you. And then 10%, that's I, 10 over 100. We can write it as the decimal 0.1. Be careful, be careful. Right, you can use your calculator there. Some people I've seen, especially when like things like 9%, the people say 0.9. If you say 0.9, that is 90%. Okay, you have to be careful there when you're converting from fraction to decimal, or from percentage to fraction then decimal. You have to be very, very careful. What else are we given? N per annum for 3 years, n is equal to 3. And then we are looking for A. You see that? Okay, you have your information like that, and then we substitute. I want you to do the substitution, and then after substitution, let's get the answer. Let's do that for 2 minutes. Right, welcome back, returns. I really hope you managed to get the answer. So let's substitute what we have here. Where there's P, we put 5,000, and we substitute. Here we can even use 0.1 for the 10% here. And then put this in the calculator. We're getting 6,500. Do you see that? It's the same answer we got. Okay, when you calculate it by for each year. Right, let's go to the next one. Right, I want you to identify here, read the question, and then identify the variables that were given and the variable that you are looking for. Okay, just for 1 minute, identify the variables that you are given and what we are looking for, and then after that, we'll do that step together, and then I'll give you time to do your substitution and calculating. Okay, let's try to do that for 1 minute. Right, welcome back, returns. So Percy invested an amount of money at a rate of 9.6% per annum, simple interest. After 4 years, he had 27,780 in his savings account. How much did Percy invest? Right, now, this is simple interest. We write our formula. Right, what we have here, after 4 years, he had this amount. So this is the A, the accumulated amount. So A is equal to 27,680 rand. And then P, how much did Percy invest? Actually, this is what we're looking for. We're looking for P. So P, we don't know what P is. We're going to look for that. And then I is equal to 9,6 over 100, or you can say 0,096. And then N is 4. N is equal to 4. You see that? And then let's substitute to our formula, and maybe let's do this together. Let's substitute into the formula. You see that? So we have our A here, we have our I, we have our N. We are looking for P. So what do we do then? We can start by finding this. Put this thing inside the bracket into your calculator. What does it give you? You must get that 27,780 is equal to P times 1,384. So this thing in the bracket there is 1,384. And then what do we do to get P? What do we do to get P? We divide both sides by 1,384. We divide both sides by 1,384. And then P is equal to 20,000. So it means Percy invested 20,000. And then after 4 years, it was 27,780. You see that? Okay. I'm going to give you the next question. You try to identify the variables that you are given and the variable that you are looking for. Okay. Let's try to do that. I'm going to give you 1 minute to identify what you are given and what we are looking for. 1 minute. Welcome back. Grade 10. Let's see. Simpiwe wants to save 49,600 to start his business. If he invests 32,000 at an interest rate of 11% per annum, simple interest, how long will he have to wait to attain 49,600? So now, what is 49,600? That is our A. Right, 49,600. And then 32,000, that's the money invested, that's the principal amount, P, 32,000. And then 11% per annum, simple interest, that's this I, which is 11 over 100, or 0,11. How long will he have to wait to attain 49,600? That's N, that's what we're looking for. Okay, right, we're going to do our substitution, and then after substitution, you try to solve for N. Okay, can you try that? Let's see. Now, this is the substitution. Let's substitute what we have. We have done our substitution there. Right, can you try to solve for N here? Can you try to solve for N? Here you can even use 0,11, it's still fine, 0,11 there. And then let's solve for N. Let's try it for 3 minutes. Welcome back, Cretans. Did you manage to solve for n? What did you do? Okay, what we do here, we have to divide by 32,000 both sides. Okay, if maybe you also distributed, there's no problem with that. Maybe you just distributed the 32,000, it's still fine. We must get the same answer, okay? Right, but now we can divide by 32,000 on both sides like this. See that? Okay? It's another alternative method. I'm not saying this is the only method. But at the end, we must get the same answer, okay? We must get the same answer. And then what we do after that, we transpose the positive 1. It becomes 49,600 divided by 32,000 minus 1 is equal to 0.11n. Okay, you see that? So this is 1.55 minus 1. Okay, and then what do we do after that? 1.55 minus 1 is 0.55. And then what do we do to get n? Divide both sides by 0.11, isn't it? Okay, 0.55 is equal to 0.11 n. Divide by 0.11, divide by 0.11. And then we get that n is equal to 5 years. You see that, Cretans? Is it difficult? It is not difficult. We must collect all the marks when it comes to financial mathematics, or in simple and compound growth. Right, let's go to the next question. It should be the last question under simple interest. At the end of 2016, Thabo invested 15,000 into a savings account, and then at the end of 2021, she had a total of 24,375. Calculate the simple interest rate that Thabo received. We want the interest rate now. Okay, I'm going to explain this one. Right, if there are any questions, 079-454-9535. Okay, at the end of 2016, Thabo invested 15,000. So it means P is equal to 15,000 into a savings account. At the end of 2021, he had a total of 24,375. A, the accumulated amount, 24,375. Calculate the simple interest rate that Thabo received. Oh, where do I find n here? So I don't have n and I don't have I. How do I deal with this? Where do you find n here? We are given n. Do you see that? Indirectly. At the end of 2016 to the end of 2021. You see that? So you have to be very, very careful here. It's at the end of 2016. So in accounting the years, we're saying end of 2017, 1, end of 2018, 2, end of 2019, 3, end of 2020, 4, end of 2021, 5. That is 5 years. So you have to be very, very careful, because end of 2016 to beginning of 2021, we may be talking about something else. That would be 4 years. You see that? So it's end of 2016 to end of 2021, which is 5 years. So it means n is equal to 5. Then we're going to solve for I. Let's substitute. We have substituted them. You see that? Right. You can distribute. You can distribute your 15,000 there. And then, but I like this one as my preference. But you can distribute. But usually you can distribute. You can start by dividing both sides by 15,000. Okay, right. And then we can transpose 1, come this side. Don't round off during calculation. Please don't round off during calculation. You use the numbers as they are. So that's why I prefer using fractions, because fractions, you have not compromised on accuracy there. They are fine. But rounding off, you are compromising on accuracy. So we round off the final answer. Right, so the fraction which ends, terminating decimal there, is fine. You can use it. So it's like 1,625 is fine. But if you have a non-terminating decimal which does not end, use it as a fraction. And then 1,625 minus 1 is equal to 5i. We're looking for interest there. And then we get 0,625 is equal to 5i. Then what we do here, divide by 5 on both sides of the equation. And then we get that I is equal to 0,125. This is the interest rate as what? As a decimal. How do we convert decimals to fractions? Do you remember? How do we convert decimals to fractions? We multiply by 100, okay? Actually, it's 100%, but sometimes people put the percent in the calculator. It's safer to say multiply by 100, and then you say 12.5%. Okay, so R is just 12.5%, which is equivalent to this. We've managed to find our, what is happening here? Calculate the simple interest rate, or the rate. Okay, for R, the rate is fine, which is I, actually. Okay, let me just maintain that so that we don't get confused. So the interest rate there is 12.5%. Okay, right. Now let's go to compound interest. We may not finish compound interest, but let's just learn something. Let's learn something about compound interest. What is the difference between simple interest and compound interest, or simple growth and compound growth? Okay, right. Right, in compound interest, interest also earns interest. What do we mean by that? Okay, let me use that example so that I can explain this thing nicely. Okay, I will use the example to explain. Interest is always calculated on the new balance. I think we'll understand this one better when we go to our example. Okay, let's just do that. Consider 5,000 Rand invested for 3 years at 10% per annum compounded annually. It means interest is added every year in a savings account. How much was in the savings account after 3 years? So let's calculate for the first year, second year, third year, just like we did for simple interest. So first year is going to be 5,000 plus 10% of 5,000, which is 500 Rand. You see that? But remember what I said. I said compound interest. Interest also earns interest. So it means second year, the 500 Rand that we have gained must also earn interest. Interest is charged on the new balance. What is the new balance? It is 5,500. So it means the 5,500 will gain interest. So it's going to be 5,500 plus 10% of 5,500. Do you see that? It's not 10% of 5,000, no. 10% of the new balance, which is 10% of 5,500, which is 550 Rand. What is happening to the interest? It is growing, it is going up. And then the new balance is 6,050. And then third year, the interest that has been gained here also must earn interest. So it's going to be 6,050 plus 10% of 6,050. What is the interest here? It's going to be 605 Rand. You see, what is happening to interest? It is increasing. And then the new balance here is going to be 6,655. So you can see that, notice that the interest increases every year. This is compound interest. Right, I have two graphs here. I want you to tell me which one represents compound interest and which one represents simple interest. I have the blue graph and the orange graph. Which one represents compound interest and which one represents simple interest? You can say your answer there. Raise your hand and say your answer. Right, the orange graph represents compound interest. Do you see that? Because the interest keeps on increasing. But simple interest is a constant difference graph, which is linear. Okay, simple interest is linear. And then compound interest is exponential. That's why the n there is the exponent. So compound interest is exponential. Remember that. Because they can ask you in the exam and say, this is showing exponential growth. And then you're wondering now, what is this now? If they say exponential growth, it means it's compounded. Okay? And then simple interest is a linear growth. Linear growth is a straight line. Because like example that we did there, 500 plus 500 plus 500. So every year is increasing by 500. So the gradient is the same. The gradient is the same. Okay? So please take note of that. And then now, again, we can use the formula instead of doing calculations each and every year, we can use the formula. This is the formula for compound interest. Let me show you the variables, then I'll give you time to copy. Right, A, just the same, the accumulated amount. P is the principal amount, the money invested or borrowed. And then I is the interest rate. And then N is the time period. It can be the number of years. In this case, grade 10, we're doing the number of years because it's compounded annually. Right, can I give you 1 minute to copy the formula and also the meaning of the variables? Let's do that in 1 minute. Right, welcome back, grade 10th. I hope you've managed to copy the formula. Right now, this is the example. It's still the same like the one we did, but we're doing it step by step. I want us to use the formula and see if we're going to get the same answer. So here our 5,000 is invested. That is, what is this? P, ne? P, that's P. P is equal to 5,000. And then N is equal to 3. Then I is equal to 10%, which is 0, 0.01, 0, 0.1, sorry, 0, 0.1 or 0, 0.10, it's fine. And then use the formula. So we substitute into the formula, and then what do we get? We get 6,655. Do you see that we're getting the same thing? Okay, right, the next one, let's do the same thing. We're going to identify what we are given and what we are looking for, and then we substitute into the formula and get the answer. Let's try to do that in 2 minutes. Identify what you're given here. Is it A, P, I, N? Then what are we looking for? You substitute into the formula and get the answer. Let's try to do that in 2 minutes. Right, welcome back, grade 10s. Percy invested an amount of an amount of money at a rate of 9.6% per annum compounded annually. After 4 years, he had 216,437 rand and 98 cents in his savings account. How much did Percy invest? What are we looking for here? We're looking for P. So we're looking for P. Then A, we have A. This is the accumulated amount. 216,437 rand 98 cents. Then I is 9.6 over 100, which is 0.096. And then N is equal to 4. Yes. Right, so we substitute into the formula what we have. We're looking for P. So what can we do? We can find this. Put this in the calculator, this whole thing. What is it? Just put it in the calculator. And then if we want to use the decimal, there should be 0.096. And then we must get 1.442919879. Don't round off during calculation. Then what do we do to get P? We divide by this whole thing. 1.442919879 both sides. Then P is equal to 149,999.9987. You see, when we round off this, we are going to get 150,000. So P is 150,000. Okay. Right. Now I'll try to explain the remaining questions. Okay, since we are left with roughly 5 minutes, let me explain the remaining questions. I'll try to be slow. Please remember our WhatsApp line 079-454-9535. If maybe there's something you did not understand, please send us the question. Right, Simpiwe wants to invest to save 461,587.19 to start his business. You see, the questions are just the same like the ones we did for simple interest, but now the difference, we're using compound interest here, and the amounts are different. Now, if you invest 300,000 at an interest of X% per annum, compound interest, for 5 years, calculate the value of X. So he wants to save this amount. So it means this is A is equal to 461,587, and then he invests 300,000, that is P. Be careful, don't make the mistake with P and A there. And then 300,000. If it's an investment, it's growth, then A must be greater than P, isn't it? Okay. And then N is equal to 5. And then we're looking for X, which is the interest rate. Okay. Let's substitute into the formula. This is what we have in the formula. And then what we do, we divide by 300,000 on both sides of the equation, and then we get this. Okay. Right. What do we do to get rid of this exponent to the power 5 there? We have to fifth root both sides. We have to fifth root both sides of the equation. And then if we fifth root here 1 plus x to the power 5, the exponent 5 and the fifth root thing will cancel each other out. We remain with 1 plus x. And then you can use your calculator. Please look for this in your calculator and then try to calculate it. If you something like this in your calculator, okay, look for this function, and then you put your 5 there, and then you put this fraction there and say equals. It will give you the answer. Right, what we get? We get that 1, what have I done? Oh, okay, right, before doing that, we have brought the negative 1, so it doesn't change anything. It doesn't change anything. But this one, the advantage, you can do this once, because sometimes writing these long decimals is a problem. So just use them as fractions and then just do everything once. Now let's just do everything once, and then we find what? We find negative 1. But if you found this is still fine, then subtract 1 from that, and then you're going to get 0.09 is a decimal. We multiply this by 100, we get 9%. See that? Then we get 9%. Right, let's do the last question. Oh, you want to copy? Let me give you time. Right. Right, just 1 minute. Let's copy. Just make a few notes for 1 minute. Right, welcome back. I hope you managed to make a few notes there. And then at the beginning of 2016, Tato invested 16,500 into a savings account. And then at the beginning of 2022, she had a total of 26,993 rand and 73 cents. Calculate the compound interest rate that Tato received if it was compounded annually. This is compound interest. So beginning of 2016 to beginning of 2022. So it's beginning of 2016. So beginning of 2017, 1, 2018, 19, 20, 21, 22. It means 6 years. Okay, so it means N there is 6. So we have A, 26,993,73. P is equal to 16,500. 16,500. Then N is equal to 6. You see that? And then we're looking for I. So we substitute into the formula. Okay, just listen here for the last one because it's just the same like the previous one. Okay, and then we substitute like this and then divide by 16,500 on both sides of the equation, and then we can even transpose or find the sixth root both sides here, sixth root both sides to get rid of this exponent, the sixth root both sides, and then we transpose positive 1 to the left hand side becomes negative 1, and then you can put this in the calculator. Please learn how to use your calculator. You must use your calculator and get the same answer. So I is equal to 0.854999995, which reduces to 8.55. We multiply this by 100, okay, percent. Then, but when your calculator, just put 100, don't put the percent, because we want to write the percent as the unit there. So it's going to be 8.55%. This is how we deal with these two formulae for simple growth and compound growth. This is your homework. You can copy the homework just for 30 seconds. Maybe you can take a picture for 30 seconds. Okay, right. So if you still want the homework, you can rewind the video and check the homework there. Okay, right. So now we're done with our lesson, and then the summary. We talked about the simple interest formula, which is this formula, and then we talked about the compound interest formula, which is this formula. Okay, so thank you very much, grade 10s, for joining us. We are going to meet next week. Next week, we're going to look at past examination questions, looking at financial maths, financial mathematics, or simple interest and growth, simple growth and compound growth, simple growth and compound growth, because we can be looking also at the growth of, let's say, bacteria. It's not about simple interest only, okay? Right, there are things that grow exponentially in life. Okay, so we're going to be looking at those. We're going to look at past examination questions. Let's meet next week, grade 10s. Goodbye.